Hello dear students, in this video I'll continue with chapter 8. Here I will discuss about continuity and solve the questions of Check Your Progress 6 of the CBSE Book student support material. I'll also solve some additional questions for practice. Now first we will see about continuity of a function. If we consider the function f of x equal to x square, if we take any point x is equal to a, we can see that the limit x tends to a, f of x, it is equal to a square, which is equal to f of a. So we say that the function f of x equal to x square is a continuous function. We don't have to take our hand when we draw this curve f of x equal to x square. So for any point x is equal to a, we have f of x, limit x tends to a, f of x equal to f of a. So we say that this function f of x equal to x square is a continuous function. Now let us consider another function f of x is equal to minus x square plus 6 for 0 less than or equal to x less than 2 and equal to x minus 1 when 2 less than or equal to x less than or equal to 4. Now the limit of this f of x as x approaches 2 from left. As x approaches 2 from left, we write that as limit x tends to 2 minus. We write that as limit x tends to 2 minus f of x. And this is equal to limit x tends to 2. Here we have to take f of x as minus x square plus 2 because we have f of x minus x square plus 6 for 0 less than or equal to x less than 2. So when x is between 0 and 2, f of x is minus x square plus 6. So limit x tends to 2 minus f of x equal to limit x tends to 2 minus x square plus 6. So this is equal to minus 4 plus 6, which is 2. So this limit is called the left hand limit of f of x at 2. Now here we can see that the left hand limit of f of x is 2. And now the limit of f of x as x approaches 2 from right. As x approaches 2 from right, we write that as limit x tends to 2 plus f of x, or this is called the right hand limit of f of x at 2. Now as x approaches this 2 from right, we have limit x tends to 2 plus f of x as limit x tends to 2 x minus 1, because it is in this place where x varies from 2 to 4. So this is equal to limit x tends to 2 x minus 1. Now this is equal to 1. Here we can see that the left hand limit. Now this limit is called the left hand limit and this limit is called the right hand limit. We can see that the left hand limit at x is equal to 2 is not equal to the right hand limit at x is equal to 2. Or if we want to draw the graph for this function, we can see that we have to draw the line here and then we have to take our hand and then again come here to draw the line f of x equal to x minus 1. Or in other words, there is some point of discontinuity, or the graph is not continuous, it is discontinuous. So we say this function is said to be discontinuous and x is equal to 2 is a point of discontinuity. So this is with respect to point of discontinuity and discontinuous function. Now having seen a continuous function and a discontinuous function, we will come to the definition of continuous function. The function f of x is said to be continuous at the point x is equal to a if its finite value at x is equal to a is equal to the limiting value of f of x at the point x is equal to a. This is nothing but the value of f of x at x is equal to a, which is f of a. This should be equal to the the limiting value of f of x at a. This is equal to limit x tends to a f of x. Or for continuity at x is equal to a, we should have the left hand limit equal to the right hand limit equal to the value of the function. The left hand limit short form is LHL, right hand limit RHL. So we should have limit x tends to a minus f of x equal to limit x tends to a plus f of x equal to f of a. Only when this condition is satisfied, we say the given function is a continuous function. Now moving on to algebra of continuous function. Suppose f and g are two real continuous functions at a real number c. Then we have f plus g is also continuous at x is equal to c. F minus g is continuous at x is equal to c. F into g is continuous at x is equal to c. And f divided by g is continuous at x is equal to c provided g of c not equal to 0. So these are some important points that we have to remember. These are the questions from Check Your Progress 6 of Student Support Material. So here for x less than 3, we have f of x is this function, and for x greater than or equal to 3, we have f of x is equal to 2. First, let us find the equation of this line. Let us take this as L1. So first to find equation of L1. Here we have 2 points. This point is minus 1 comma 3, and if we draw a straight line here and here, we have this point as 2 comma 1. Now when we have 2 points, we can find the equation of the line as y minus y1 equal to y2 minus y1 upon x2 minus x1, which is the slope of the line, into x minus x1. So we have, this is 3 minus 1. So we have x1 y1 as 3 minus 1 and x2 y2 as 2 1. So if we take x1 y1 as 3 minus 1, we have y plus 1 equal to 1 plus 1 upon x2 minus x1, 2 minus 3 into x minus 3. So we have y plus 1 equal to minus 2 into x minus 3, or we have y is equal to minus 2x plus 5. Now the equation of this line is f of x is equal to minus 2x plus 5, and the equation of this line is f of x is equal to 2. Now we have the equation. F of x is equal to minus 2x plus 5 when x is less than 3 and it is equal to 2 for x greater than or equal to 3. Now we have the function in our hand. The first subdivision, what y value is the function approaching as x approaches 3 from left. So as x approaches 3 from left, we have to take this function. First subdivision, limit x tends to 3 minus f of x, it is equal to limit x tends to 3 minus 2x plus 5, or it is equal to minus 1. So the y value approaches minus 1 as x approaches 3 from left. So here the value is minus 1. Now moving on to the second subdivision. What y value is the function approaching as x approaches 3 from right? So limit x tends to 3 plus f of x. Here if we see, as x approaches the limit 3 from right, we have limit x tends to 3 plus f of x. As x approaches 3 from right, we have f of x is equal to 2. Here we have written f of x equal to 2 for x greater than or equal to 3. And then the next subdivision. So what y value is the function approaching as x approaches 3 from right? So the value is 2. Next subdivision, what if any is the actual y value at x is equal to 3? Here we can see that there is a circle which is given. It means here x is equal to 3 is not included. We have f of x is equal to minus 2x plus 5 for x less than 3. Whereas here we can see a darker point. So it means this point 3 is included. So f of x is equal to 2 for x greater than or equal to 3. So at x is equal to 3, f of x is nothing but it is y. F of x is equal to 2. Now it is asked what can you conclude about the function. We can see that the left hand limit at 3 is not equal to the right hand limit at 3. Therefore the function is discontinuous. Since left hand limit at 3 not equal to right hand limit at 3, f of x is discontinuous. And x is equal to 3 is a point of discontinuity. Next question, following on the examples of some continuous functions, reflect and discuss with your friends. First subdivision, a constant function f of x equal to c is continuous everywhere. Now let us prove this. If we take f of x so here f of x equal to c, where c is a constant, c is a real number. Now let us take, let k be any real number. Then limit x tends to k f of x, it is equal to limit x tends to k c, which is again equal to c. Therefore we can see that limit x tends to k f of x and also f of k is also equal to c, is equal to f of k. Therefore we can see that f is continuous at c, that is at every real number. F is continuous at k, that is at every real number. So we can say that a constant function f of x equal to c is continuous everywhere. Then the next one, f of x equal to mod x is a continuous function on R. Now if we take f of x equal to mod x, it is nothing but it is minus x when x less than 0 and x for x greater than or equal to 0. Now this you must have studied in the types of functions and graphical representation of functions. Now let us take the left hand limit at 0. The left hand limit at 0 is limit x tends to 0 minus f of x. This is equal to limit x tends to 0. As x approaches 0 from left, we have f of x as minus 0, which is 0 again. Then the right hand limit at 0 equal to limit x tends to 0 plus f of x. Here when x approaches 0 from right, we have f of x equal to x for x greater than or equal to 0. So limit x tends to 0 plus f of x will be limit x tends to 0 x, which is again 0. Also we have f of 0 equal to 0. Here f of x equal to x for x equal to greater than or equal to 0. So f of 0 is also equal to 0. So we have the left hand limit at 0 equal to the right hand limit at 0 equal to f of 0, which is the condition required for a function f to be continuous, which means f is continuous at x is equal to 0. Now for x less than 0 and for x greater than 0, f of x is a polynomial function. When x less than 0, f of x is minus x, and for x greater than 0, f of x is x, and when x is equal to 0 also f is continuous, and all polynomial functions are continuous. We have mod x is a continuous function. So this is how we have to go about when we are asked to prove that a function is a continuous function or not. Now moving on to the next one, polynomial functions are always continuous. So let us take, let P be a polynomial function. So we have P of x as a0 plus a1x plus a2x square plus up to etc. plus an x raised to n. Here a not equal to 0 and n belongs to the set n of natural numbers. Here we have clearly limit x tends to c, p of x is equal to p of c, where c is any real number. Therefore, we can see that p of x is continuous at c, that is at all real numbers. We have taken limit x tends to c, where c is any real number of p of x, and if we put p of c also, we will get the same value. So p of x is continuous at c, hence every polynomial function is a continuous function. Now these are some additional questions which I have taken to understand the concept of continuity better. First one, prove that the function f of x equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and at x is equal to 5. Now to prove that a function is continuous, it is enough if we prove limit x tends to that value f of x, it is equal to f of c. If we prove this, it is enough. So first let us take at x is equal to 0. At x is equal to 0. Now limit x tends to 0, f of x equal to limit x tends to 0, 5x minus 3. This is equal to minus 3. And f of 0 equal to 0 minus 3, which is minus 3. So this implies limit x tends to 0, f of x equal to f of 0. Therefore, f is continuous at x equal to 0. Now let us take the next one at x is equal to minus 3. At x is equal to minus 3, limit x tends to minus 3, f of x, it is equal to 5 into minus 3, so it is equal to minus 18, and f of minus 3, it is also equal to minus 18. So which implies limit x tends to minus 3, f of x equal to f of minus 3. Therefore, f is continuous at x is equal to minus 3. Now at x is equal to 5. Limit x tends to 5, f of x, it is equal to 5 into 5 minus 3, which is 22, and f of 5 is also equal to 22. So we have limit x tends to 5, f of x equal to f of 5. Therefore, f is continuous at x is equal to 5. So these are the steps. Next question, examine the continuity of the function f of x is equal to 2x square minus 1 at x is equal to 3. So here at x is equal to 3, we have limit x tends to 3 f of x as 2 into 3 square minus 1. So it is 18 minus 1, 17. And f of 3 is also equal to 17. So from this we have limit x tends to 3 f of x equal to f of 3. Therefore, f of x is continuous at x is equal to 3. Next question, prove that the function f of x is equal to x raised to n is continuous at x is equal to n where n is a positive integer. So again the same steps. At x is equal to n, limit x tends to n f of x equal to n raised to n, and f of n is also equal to n raised to n. So from this we have limit x raised to n f of x equal to f of n. Therefore, f is continuous at x is equal to n. Next question, f of x is equal to 1 by x minus 5, x not equal to 5. Here we have to examine the following functions for continuity. That is at any point x which is not equal to 5. So let us take, let c be any real number. Now limit x tends to c f of x. It will be limit x tends to c 1 by x minus 5, which is 1 by c minus 5. Also f of c equal to 1 by c minus 5. So from this we have limit x tends to c f of x equal to f of c. Therefore, f is continuous at c, that is at all real numbers, and hence f is a continuous function at all real numbers except 5. Next question, f of x is equal to mod x minus 5. Now, f of x equal to mod x minus 5 means it is equal to minus of x minus 5 when x minus 5 less than 0. That is when x less than 5. When x less than 5 and it is equal to x minus 5 when x greater than or equal to 5. Now we have to examine the continuity at x is equal to 5. Now let us take the left hand limit at 5. It is equal to limit x tends to 5 minus f of x, which is equal to limit x tends to 5 minus of x minus 5. So it is 0. Now the right hand limit at 5. It is equal to limit x tends to 5 plus f of x, or it is equal to x tends to 5 x minus 5. This is again equal to 0. And also we have f of 5 is when x is equal to 5, we have f of x is equal to x minus 5. So when we substitute x as 5, we get 5 minus 5 equal to 0. Therefore, left hand limit at 5 equal to right hand limit at 5 equal to f of 5. So from this we can see that f is continuous at x is equal to 5. Now for x less than 5 and for x greater than 5, we can see that f of x is a polynomial function, and polynomial function is continuous, that we already know. So for x less than 5, x greater than 5, f of x is continuous, and it is also continuous at x equal to 5. Hence f of x is a continuous function. Now moving on to the next one is the function f defined by f of x equal to x if x less than or equal to 1, 5 if x greater than 1, continuous at x is equal to 0, at x is equal to 1. So first let us take at x is equal to 0. At x is equal to 0, here we can see that for x is equal to 0, f of x, we have to take this function x. So limit x tends to 0, f of x, it is equal to limit x tends to 0 x. This is equal to 0. And f of 0 is also equal to 0. Therefore, we have limit x tends to 0 f of x equal to f of 0. Therefore, f is continuous at x is equal to 0. Now we will take x equal to 1 at x equal to 1. Now first let us take the left hand limit at x equal to 1. Left hand limit at x equal to 1 is limit x tends to 1 minus f of x. This is equal to limit x tends to 1 x, which is 1. And the right hand limit at 1 is limit x tends to 1 plus f of x. This is equal to limit x tends to 1, 5, which is 5. So we can see that the left hand limit at 1 is not equal to the right hand limit at 1. So we have, since left hand limit at 1 not equal to right hand limit at 1, f is discontinuous at x is equal to 1. So it is continuous at x is equal to 0 and it is discontinuous at x is equal to 1. Next question, find all points of discontinuity of f where f is defined by f of x is equal to 2x plus 3 if x less than or equal to 2, 2x minus 3 if x greater than 2. So if we have to find the points of discontinuity, we have to find the left hand limits and the right hand limits and check whether they are equal to f of that limit. So first let us find left hand limit at 2. It is equal to limit x tends to 2 minus f of x, which is equal to limit x tends to 2, 2x plus 3. Since for x less than or equal to 2, we have f of x is equal to 2x plus 3. So this is 7. Now the right hand limit at 2. It is equal to limit x tends to 2 plus f of x. This is equal to limit x tends to 2. For x greater than 2, the right hand limit, we have f of x is equal to 2x minus 3. 2x minus 3, which is 1. So we can see that since the left hand limit at 2 is not equal to the right hand limit at 2, f is discontinuous at x is equal to 2. And if we take for x less than 2, we have 2x plus 3. It is a polynomial function which is continuous. And for x greater than 2, we have 2x minus 3. It is a polynomial function which is again continuous. So the only point of discontinuity is x equal to 2. Now the next question, find all points of discontinuity where f is defined by f of x is equal to mod x plus 3 if x less than or equal to minus 3, minus 2x if minus 3 less than x less than 3, and 6x plus 2 if x greater than or equal to 3. So here we have to examine 2 points, minus 3 and 3, to check the points of continuity or discontinuity. So first let us take at x equal to minus 3. Now left hand limit at minus 3 equal to limit x tends to minus 3 minus f of x. This is equal to limit x tends to minus 3 mod x plus 3. Now here if we substitute x as minus 3, we get 3 plus 3, 6. Now the right hand limit at minus 3 equal to limit x tends to 3 minus 3 plus f of x. This is equal to limit x tends to minus 3 minus 2x, because f of x equal to minus 2x when x greater than minus 3. So this is equal to 6. And f of minus 3 is also equal to, here f of minus 3 is mod minus 3 plus 3, which is again 6. Therefore, let us take this as 1, 2 and 3. From 1, 2 and 3, f is continuous at x equal to minus 3. Now let us take at x is equal to 3. Now the left hand limit at 3, it is equal to, when x is less than 3, we have minus 2x. So it is limit x tends to 3 minus f of x, which is limit x tends to 3 minus 2x, which is minus 6. Now the right hand limit at 3 is limit x tends to 3 plus f of x. So it is limit x tends to 3. So 3 plus, when x greater than or equal to 3, we have f of x as 6x plus 2. 6x plus 2. This is 20. So here we can see that the left hand limit at 3 is not equal to right hand limit at 3. So since left hand limit at 3 not equal to the right hand limit at 3, f is discontinuous at x is equal to 3. Now if we see at all the other points, f is continuous since f is a polynomial function. So the only point of discontinuity is x is equal to 3. Now we have next question, that is finding the constants when a function is continuous or discontinuous. Find the relationship between a and b so that the function f defined by f of x equal to ax plus 1 if x less or equal to 3, bx plus 3 if x greater than 3 is continuous at x is equal to 3. So here it is given f of x is continuous at x is equal to 3. This implies left hand limit at 3 equal to right hand limit at 3 equal to f of 3. Now let us find the left hand limit at 3. It is equal to limit x tends to 3 minus f of x. Now limit x tends to 3 minus f of x will be limit x tends to 3 ax plus 1. Limit x tends to 3 ax plus 1. So it is 3a plus 1. And the right hand limit at 3, it is equal to limit x tends to 3 plus f of x. It is limit x tends to 3 bx plus 3. So it is 3b plus 3. Now from 1 we have these two equal. Let us mark this as 2, 3 and f of 3 is 3a plus 1. So from all these, therefore 1, 2, 3 and 4 implies 3a plus 1 equal to 3b plus 3. So from this we have 3a minus 3b equal to 2 or a minus b equal to 2 by 3. So finally we have a is equal to b plus 2 by 3. So this is the relationship between a and b. From a minus b equal to 2 by 3, we get a equal to b plus 2 by 3. Next one, for what value of lambda is the function defined by f of x equal to lambda into x square minus 2x if x less or equal to 0, 4x plus 1 if x greater than 0, continuous at x is equal to 0. What about continuity at x is equal to 1? Now we have to find lambda for which this function is continuous at x is equal to 0. So at x is equal to 0, left hand limit at 0, this is equal to limit x tends to 0 minus f of x. This is equal to limit x tends to 0 lambda into x square minus 2x. This is 0. And the right hand limit at 0, it is equal to limit x tends to 0 plus f of x. This is limit x tends to 0, 4x plus 1. This is equal to. Now here we can see that since the left hand limit at 0, it is not equal to the right hand limit at 0. F is discontinuous at x is equal to 0. So for no values of lambda, whatever be the value of lambda, f is not going to be continuous at x is equal to 0. Hence for no values of lambda, f is continuous at x is equal to 0. Now moving on to x is equal to 1. For x is equal to 1, limit x tends to 1, f of x, it is equal to, here we have x, limit x tends to 1, f of x, we have f of x as 4x plus 1. So it is limit x tends to 1, 4x plus 1. This is 5. And f of 1 is, again, when we for x greater than 0, we have f of x as 4x plus 1. So f of 1 will be 4 plus 1, which is again 5. Therefore, limit x tends to 1, f of x equal to f of 1. Therefore, f is continuous at x equal to 1. Next question, find the values of k so that the function f is continuous at the indicated point. F of x is equal to kx square if x less than or equal to 2, equal to 3 if x greater than 2 at x is equal to 2. So here it is, the function is given and it is given f of x is continuous at x is equal to 2. We need to find the value of k. Now the left hand limit at 2, it is equal to the right hand limit at 2, it is equal to f of 2. Since f is continuous at 2. Now left hand limit at 2, it is equal to limit x tends to 2 minus f of x. This is equal to limit x tends to 2. When x approaches 2 from left, we have f of x as k square. So it is limit x tends to 2, kx square. So it is equal to 4k. Let us mark this as 2. And then the right hand limit at 2, it is equal to limit x tends to 2 plus f of x. Now f of x takes the value 3 when x greater than 2. So it is limit x tends to 2, 3. This is equal to 3. Let us mark this as 3. And f of 2 is again equal to 4k. Let us take this as 4. So from all these 1, 2, 3 and 4, we have 4k equal to 3, which means k equal to 3 by 4. So this is how we can use continuity, discontinuity, all these to find the value of k or lambda if it is asked. And we can also prove whether a function is continuous or discontinuous using this condition. I hope this video was useful for you. Thank you for watching.